Welcome Pure Maths 3 students. We're going to continue again today to do some more differential equation questions. Today I'm doing question 10 parts A and B from, I think it is June 2020, paper 3-3, I think. And there are two parts to this question. The first part is this part here, which is a 4-mark question, and that works out to be 5.86 or roughly 5.9 minutes. So we want to get this done in under 6 minutes. Should be able to do that. A little bit different, this one, than the previous ones. So let's have a look. We've got this tank. It's in the form of a hemisphere. The axis is vertical, the lowest point is A, the radius is R, and the depth of the water at time t is H. At time t equals 0, the tank is full. So an important point there, of course, is at t equals 0, H is equal to the radius. Right, because H should be all up the way up there. Okay, so just be aware of that. All right, let's move on. At this instant, a tap at A is open and the water begins to flow out at a rate proportional to that, the square root of H, and the tank is empty at T is 14, which means at that point H equals 0 at that point. Okay. So let us now work through this. We've got to show that H and T satisfy a differential equation of the form dH dt is equal to minus B, which is some positive constant, all over 2r h to the power of 1/2 minus h to the power of 3/2. Okay. Well, we know that the water is flowing out at a rate proportional to this. So what we're saying here is the volume dV dt should be equal to, and it's proportional and it's flowing out, so it's going to be negative, a negative constant times the square root of h. So that's one thing we know. Now I'm going to take this equation here and get dV dH. But first, up here, I will just perhaps go V equals, and I'm just going to open up that bracket. So I should get pi RH squared minus 1/3 pi H cubed. Okay, so that's what I've just done there. Now, when I differentiate that, I should get 2 pi RH minus, and then that 3 times the 1/3, so that just becomes 1, so it'll be pi H squared. At this point, I'm looking at trying to form this, and I can see I've got a H here, and a dt here. So I'm thinking that dH dt should be equal to dV dt by dH dV. So I'm going to need to do the reciprocal of this one here. So I should get is equal to, let's have a look, minus K square root H all over, and then I'll have this one here, the dV dH, which I've done the reciprocal of, on the bottom, minus pi H squared. And now if you look, since we've got H's on the bottom and the top, we can use our index laws here. So it'll be minus K, and then along the bottom we'll have 2 pi r, and then since we should end up with an h to the power of a half, since h to the power of a half divided by h should be 1 over h to the power of a half, minus pi, and this h is going to become h to the power of 3 over 2, which is what we kind of want. So my last step would be to go, well, that's equal to minus some constant, positive constant b, over 2 pi r h to the 1/2 minus pi h to the 3 over 2. Okay, at this point, I'm just going to drag up another question here. This is part B, and this is worth 8 marks. I've got to solve the differential equation and obtain an expression in terms of t in terms of h and r. Now this is an 8-mark question, and so this means we should spend a maximum, well, it's really 11.7 minutes. So that's what we'd be allowed on that. Okay, well, I'm going to take this here, and I'm going to separate the variables. So I've got dh on this side, so I'll pull across the 2 pi r h to the 1/2 minus pi h to the 3 over 2 dh equals, and then I will pull across the dt over to this side, which has got my minus b on it, so it'll be minus b dt. And at that point, I would decide that I'm going to integrate both sides. Now, what does this get us? Nice and easy. On the right hand side, we'll get bt plus c. Now, on this left hand side, it's a little bit more complex. We'll have the 2 pi r. Remember, the radius is a constant in this situation, so we're just working with this h. We're going to raise its power, so it becomes 3 over 2, and then we're going to divide by 3 over 2, which is the same as timesing by 2 over 3. That's the first term. It's going to be like this. The second term will raise the power, so this will become to the power of 5 over 2. Then we're going to divide by 5 over 2, so this should end up being same as 2 over 5. And now we can simplify, so our next line, it should read 4/3 pi r h to the 3 over 2. Subtract 2/5 pi, h to the 5 over 2 equals minus bt, that's horrific, bt plus c. Now, we're going to use some of this data. T equals 0, h equals r. Now, at time equals 0, then we'll get this 4/3 pi. Now, h equals r, so we'll end up with 4/3 pi r to the power of 5 over 2, just using my index laws there, minus 2/5 pi r to the 5 over 2 again, equals now minus b times t. Now t is 0, so that becomes 0, and this will be c. Now over here we can go therefore. Now 4/3, notice that we've got the same like terms here, so we're going to do 4/3 take away 2/5, and that's going to give me 14/15. Yes, pi r to the 5 over 2. And that is what C is. The other thing that we know is that when t equals 0, when t equals 14, h equals 0. And so at this point, we can now find out what b is. So what we do here, on the left-hand side, since h is 0, anything that 4/3 pi r squared h is going to be 0. And then the 2/5 pi h to the power of 5 over 2 is also 0. So I get 0 equals negative 14b plus c. Now c is 14/15 pi r to the power of 5 over 2. And therefore, 14b is equal to 14 over 15 pi r to the power of 5 over 2. Therefore, we can say that b, because we're going to divide both sides by 14, equals 1 over 15 pi r to the power of 5 over 2. Now, at this point, we can now write out our formula. So, we have this. 4/3 pi r h to the power of 3 over 2, subtract 2/5 pi h to the 5 over 2 equals, what did we say b was? Minus 1/15 pi r to the 5 over 2 plus what we said c was, which is 14 over 15 pi r to the power of 5 over 2. Now, we are trying to put h in terms of, we're trying to do t in terms of h and r. So I want to get my t by itself. Oh, and I haven't got my t in here because I've just put my b in, minus b, and I forgot to put my t in. So there's my t there. Okay, right. So the next thing I would do is move my t to the left side to make it positive, and move all of the stuff that's already on the left-hand side across. So that will give me 1/15 pi r to the 5 over 2t equals, and then I'll have my 14/15 pi r to the 5 over 2 minus 4/3 pi r h to the power of 3 over 2, and that negative 2/5 as I move it across becomes positive 2/5 pi h to the power of 5 over 2. Now, what I'm going to do is I'm going to, at this point, times by 15 over pi r to the power of 5 over 2, both sides, to get rid of everything and leave me with a t on the left hand side. So I'll get a t equals, now when I times by 15, this first term here will become 14, and you'll note that 15 on the denominator cancels out because I'm timing by 15, but also the pi r to the power of 5 over 2 cancels out because that's on the bottom of this denominator. This is what I'm doing. Okay, now my next term, I'm timing by 15. 15 times minus 4 over 3 is going to be minus 20. The pi's cancel out again because I've got a pi in the denominator. The r, I'm going to have h to the 3 over 2 all over. Now, r divided by r to the 5 over 2 should become r to the 3 over 2. That's quite messy there. Let me just see if I can fix it up to the 3 over 2. And then my next one, I'm timesing that 2/5 by 15, so that should become 15 over 5, 3, so it should be 6, I think, 6. The pi's cancel out, and I'm going to have h to the 5 over 2 divided by r to the 5 over 2. Now, this is actually quite messy. Let me just rewrite that a little bit. Okay, so what have we got? T equals 14 minus 20. Now, notice that we've got h and r both to the 3 over 2, so I'm going to go h over r to the power of 3 over 2, and then plus 6, and again I've got h over r, and they're both to the 5 over 2, so I'll go to the 5 over 2, and that would be my final answer. Well, I hope that helps, guys. I'll try and do one or two more before the end of the holidays.